Hi everyone, my name is Yuting Liu. This video is for CSCI 29 Python for Data Science spring course at the Harvard Extension School. My project is to create a classification model to identify between dogs and cats. This was a Kaggle challenge many years ago. The dataset contains 25,000 images with both dogs and cats. Here I will use about 5,000 of them to train, test, and validate my data. Here are our staff members for spring 2018. The project will be done using convolutional neural network model in Jupyter Notebook. The reason why I was interested in this topic is because this was showed as an example of machine learning in the lecture. And I want to do this to test whether it can identify my 3-year-old golden retriever and to classify it as a dog, and also for further learning purposes. The model could also be used to identify similar concepts between images such as birds versus flowers and so on. The steps are followed by generating text file for 5,000 pictures, plot the image with labels, generating convolutional layers, tune some of the parameters, and batch samples to test the accuracy. At the end, I will load Bailey's image to see how the result is. The more training data you feed into the model, the more accuracy it turns to have. So here are the required libraries and files that I will use: NumPy, Matplotlib, TensorFlow, TF-Learn, Image Preloader, Image, Math, Globe, OS, Random, Kaggle image datasets. So we mainly will use TensorFlow and TF-Learn, Matplotlib to plot the image, Globe, OS, and Random to write the text files. You can find my dataset locations from the link below and also the URL of the notebook itself. Here are all of my references. These are very useful resources and reference websites on convolutional neural network models, steps to and examples of how it could be done. So next, I want to take you to my notebook and explain some of the coding. So first step, I want to install all the necessary libraries and import them to my notebook. So the image is downloaded from Kaggle. The sizes are very big. It is very hard to do this without using AWS. So instead, I deduct the image to 5,000 pictures versus the 25,000 images that it originally have. All the cats and dog images are stored in the same folder in orders, as you can see from this training file that I have. So we can see here are all the dogs in the bottom and all the cats on the top. So this means it is very important to shuffle the data so these images will be a good mix. So I will set my training percentage as 50%, test percentage as 30%, validation percentage at 20%, and shuffle the image. Next, I want to open all the images and create text files for training, test, and validation. So if the file name is a cat, then it will add a 0 on the file path. If the file name is a dog, it will add a 1. You can see the text files it created after this step. So for my training data, have all the file name with a 1 if it's a dog and a 0 if it's a cat. Also for testing and validation. So next, we can load the image and change the image shape to lower pixels. As you can see it here, I changed it to 64. I found this number is very helpful on my end. Of course, the bigger picture, the more clear the image will be, but the more processing power it will use. So in my case, it is good to keep it smaller. Then we can look at the shape of the image and also the label. And after that, we can use a matplotlib to show a random image. So in the next step, we want to make our model. So first, we want to define the placeholder. The reason this shape is none and 2 is because we have two values. The dog is and cats are 1001. Then we create a model with convolutional layers and fully connected layers. I used 3 convolutional layers and 2 fully connected layers. You can follow the standard architectures on this, and the reference list in the slides are again very helpful. Then we want to set the sessions and variables. You can tune the parameters too. I guess the more layers, the better it will be, but because my images are not that much, so I didn't use a higher number of it. So next, we want to input images, labels, and batches to train and optimization. So we are testing the accuracy rate with the simples. The more simples, the longer it will take. For every 100 iteration, we'll print accuracy, and the accuracy seems to increase after each iteration, as you can see here. If we want to increase the accuracy, we could also increase more layers and use more images to train. For my example, the more iteration, the better I found. But due to my computer's low processing speed, I had it as at a low number. Also, the sample size, it can be higher based on how many images that you have. But again, my sample size is smaller. So next, we want to load the image of Bailey and see how it will perform. So we want to load this image over here and see how the computer will identify it. After I load the image, I resize it to 64. And then you can see the array of the image. Then I plot the image here. So next, we predict if it is a cat or it is a dog. So here are the coding for that. At the end, Billy is a dog. So there we go. Alright, thank you so much for watching this video. I hope that you found some of the details are helpful for future references. And thank you again. Have a great summer.